The following session recording is brought to you by Vulcan Real Estate.
Well, first off, we want to say thanks for inviting us to compete. We've been involved with NAIOP for a long time, and so it's a great opportunity for us to do something fun. It's fun to be an architect and design things. It's even more fun when you get to do something, you get to dream a little bit more and kind of, push the envelope. So NAIOP came to us and said, well, what if we think about how things are going to be in 2020? It's only 7 years away, so it's not that far. We had a lot of crazy ideas. We let ourselves go a little bit, but then we pulled ourselves back, to 2020. In our discussion, we got so futuristic, things were just sort of being 3D printed in our homes, or we were teleporting the products, so we said, well, that's probably not going to happen, and it might put a few of us out of business if it just got, teleported to your home. But there's going to be a lot of changing needs. There's going to be a lot of new technology that comes online. But in our presentation, we really tried to focus on what's available today to come up with something that's really realistic. Panattoni helped us price our building, and you'll see some stats on that later. It's a more expensive building, but that's what we're seeing. We're seeing a lot of investment go into these facilities. And Prologis looked at a few examples of current and then some kind of similar types of projects, so we could compare those. So we want to say thanks for their help. So what's an e-fulfillment center? A lot of people are talking about it. I'm curious, how many people have been in a fulfillment center? Okay, so a lot. I know it's a pretty sophisticated audience. You, more than most people, understand how this is happening, okay? And Rick talked a little bit about it. I'm a person who's really happy not to have to go to a store, so this is something that I really support. We're going to show you a few slides. I'm going to go through this. Is a bit of what Rick talked about, but basically we know goods are produced in a factory. Okay, they come to a distribution building or fulfillment center. They come to the store, and if you're not me, these people go in and buy it. Okay, so in the e-fulfillment model, much is the same, right? Things are still being made, whether it's overseas or they're being made here in the US. They find their way either by rail or truck to a distribution building. What's different is now guys like me want to just go on their iPad or their phone and buy it. It comes to the distribution building, and hopefully it's waiting for you in one piece when you get home. Okay. So in 2020, e-commerce is growing. So this is really where it starts to get interesting, right? Is that to what extent are people going to be purchasing online in the future, more and more? So again, a lot is the same. The goods are making their way to a distribution building. A lot of goods. So we're going to have all the online commerce and store commerce. We see a lot of facilities where this is being mixed. But then this is where it gets more interesting. Because speed to market is so important, these buildings are going to be located closer to urban centers. And this is a critical part of the equation, is getting it to people as fast as possible. So as a consequence, not only are the buildings bigger because you've got stores and online commerce, but they're going to be more vertical because they're going to be located on more expensive land near urban centers. And that has a lot to do with the design changes. Okay, so this is a rendering we did of an actual project. This is what a lot of these projects were like. They're in low-cost land located far away. But there are examples already of projects where land values are higher and buildings have gone vertical. Okay, so this is a really key point, because I think when we think about 2020, again, there are all these components that we used in our design really kind of already exist out there. Aesthetics can be more or less important depending on where you are. If you're in the middle of nowhere, it's pretty simple. Cities, clients, community groups aren't as important. There are lots of examples where projects are located near urban areas, and all those groups are influencing the design. And here's a good example of a vertical building that obviously has a lot of investment in the aesthetics. So, all right, here we go. This is your typical distribution building where the product comes in, it's stored in the middle of the building, it's picked or sorted, and goes out of the building. The offices are typically located in the corners. They're pretty far away from where a lot of the picking and sorting is going on, where a lot of the action is happening. Technology is being infused through these projects. This is showing a VNA, very narrow aisle, with high pile storage. There are a lot of conveying systems, pretty sophisticated conveying systems that are in place already. This is a huge infrastructure cost for the people developing these, the users. And there's a lot of these are automated, so there's more robotic systems. I like this slide because the machine's got little eyeballs. I think that even from our design, things will evolve to where there's more automated, the actual picking of products. So I think it'll get more and more sophisticated even from where we are. And I think this is a great example. This is a picture of a port in Denmark where the whole port is highly sophisticated and automated. So, it just makes you realize that it kind of helps stretch your imagination for what can be. I mean, here are these vehicles transporting cargo throughout this port, and they're not manned. All right, so here we go. Now we get to the design, the fun part. We basically, in a lot of these buildings, there's action happening on both sides of the building. So we basically turned the design inside out. And what we did is in our concept, the product travels through the building, okay? So it's offloaded and onloaded in the same central core. So our speed bay is double loaded in the middle. So here, this gives you some statistics on the site. It's about 30 acres in this example. I think the thing that's interesting here is about 70% of the area is off the floor. So the building's gone significantly more vertical. So as I mentioned, product comes in. We use a conveyor to transport the product through the facility. So vehicles, and here you see these trucks are parked. The trucks could just literally pull up and be offloaded. Rail could pass up to the building, and containers could be offloaded into the facility. And they travel into the building where they're offloaded, and then eventually in this sort zone, the picking will happen, and they'll be loaded back into those containers and shipped out. The materials will move out and vertically. So there's a conveyor system that will bring products up and down to the 4 levels of the mezzanine. So these purple circles indicate where pretty sophisticated and automated elevator system, to simplify it, would bring those products to and from. And this is all automated, and this technology exists and is currently being used today. So in this section, you can see the conveyor in red. It's a key component to how this works. The picking area for offloading and then picking and packing the products. All the storage. And these floors are about 15-foot floor to floor. It could vary on the user. And that ties into the future reuse of the project. And then we have a command and control. So we took the office and the command and control and we put it on the roof. And what this does is it allows you to see pretty much the whole operation from one centralized place. So it's a big improvement from the office being stuck out on the corner. So here you can see, product will come out. The vertical transportation, and this will be, again, it's all automated. These aren't people driving forklifts, okay? These are programmed devices, robotic devices that'll transport product and also track where the product is within the warehouse. And then once it's packed for a customer, it goes back into the container, and that container at the end of the cycle is loaded onto the vehicle. In this slide, you can kind of see everything, and you can see the command and control at the top. You'll see a little bit more about that later. So it's really important that this be a sustainable building. That's just the lay of the land these days, and it's going to become more and more important. So in this slide, you can see photovoltaics, you can see a green roof, and adjacent to the office on the top. The big blue horizontals are a water collection system, and the goal for this project would be net zero. This is a main entrance that would transport all the employees that in the office area up to the roof. And the roof environment's really different now. There's a lot of talk about creative office space. This would be a creative office space. Access to natural light, access to the green roof. The office is connected to the command and control, which looks over the whole operation. And so then what happens? Okay, the building is a panelized system, could be lots of different materials, but that's important for the reuse because in the future, watch closely, it could be converted to residential or office. The core dimensions of the building work for that, and there's ample site area for parking and amenities. So part of the competition was to look at numbers and consider reality. It's an expensive building, $120 a square foot. It's an office. Those are office numbers. That includes solar and the green roof. Some of these buildings are fully conditioned, so it's depending on where you are. So in the Inland Empire, we might be looking at land, $12, $24 under the building for $4.20 annualized rent. The Japanese model has significantly higher land cost, but $14 annualized rent. So our building, when we run the numbers on $30 land, which is only $20 under the building, the rents are $12.75. So pretty different from where we are today. So this pulls it all together.